are the ones with the tick marks. The two sides that are congruent are called the legs. And so think about it literally like you have two legs that are the same length, right? An isosceles triangle has two legs that are the same length. So they will be marked typically for you, hopefully, with these pieces right here called a tick mark. So I do want us to just write that right next to it, a tick, T-I-C, tick mark. Okay, and so those tick marks do show us side lengths that are congruent. Side lengths that are congruent. So you've got two sides that are exactly the same. You also, though, have a third side, right, that is not congruent to the other two sides. So that third side, that is the one that's the different length, is called the base. And don't let the word base fool you into thinking that it has to be at the bottom. It does not have to be at the bottom. Base just means it's the side that is not congruent to the other two. Now, in coordination with those sides and with those congruent sides are some angles as well. There are two angles that are on the base that are called base angles. So they're right down here. What do you notice about those two base angles?
They're the same.
How do you know that?
Because they both have the little circle things.
Yes.
No, you go ahead and answer.
No, you already said what I was going to say.
Okay, aggressive. So these two right here are your base angles. They are literally the angles on the base. They have these two things right here are called arc marks, A-R-C, an arc mark. And again, they show angles that are congruent. So now you've got your two angles that are congruent at the bottom. Those are your, right, those are called your base angles down here, the congruent two. So let's say, let's just say one of these angles is 50 degrees, right? What does that mean this angle down here has to be?
50 degrees.
Also has to be 50 degrees. Now, there's one more angle in the triangle, and that's the angle that is across from the base. And it's the angle essentially that's all by itself. It's the one that's not the same as the other two. So it's this angle up here. It's called the vertex angle. Now, notice that there's no arc mark on that one at the top. I put two arc marks to show that it's different than the ones at the bottom, okay? So if, right, in my picture here, we said these two bottom ones are 50 degrees, what does that mean the vertex angle at the top has to be, Summer? And what does that angle have to be?
80.
Why does it have to be 80? Sydney, did you say Sydney? Sydney, thanks.
50 degrees or 50 degrees.
Good, the whole triangle is 180, so that would be that this vertex angle up at the top is 80 degrees. Great. That's okay, all good. But you knew that it's different, and that's what's important. It's different than the other two. Awesome. All right, so again, remember, the legs of the isosceles triangle are the two that are congruent, right? So think about literally your legs are congruent. And then the two angles that are across from these two legs are the ones that are congruent. So now I've got two different theorems for you here. And theorems just mean a rule that we follow. Can I have somebody read my first one that says if two? If two, can I have somebody read it? Who wants to read? Anyone, I don't care. Brian, thanks for making eye contact. Read.
If two sides of a triangle are congruent, then the two angles opposite to the sides are congruent.
Thank you. Okay, so here's what it says, essentially. If I tell you, right, if I give you a picture and I show you that these two side lengths have tick marks, if I tell you those two sides are the same, automatically the two angles that are directly across from those sides have to be congruent. So we go directly across, almost like diagonal, and that tells me that angle C and angle B have to be congruent. The converse of that theorem. Converse means the opposite of that theorem. So the opposite of that theorem says, if I tell you that these two angles, angles C and B, are congruent, then go across from the two angles, the two sides also have to be congruent. So you can go kind of either way for those problems, but it's just knowing that in an isosceles triangle, you have two sides that are congruent, two angles that are congruent. Okay, that's all that an isosceles triangle is. So let's try some practice problems that include some algebra. Hooray, your fave, algebra.
Why does it keep on coming back?
Oh my gosh, because geometry is algebra with a picture. Oh, I literally tell you this all the time. Put your phone away. Thank you. Every time. All right, first one. Let's solve for x. Then we're going to find the measure of angle GFH. So the first thing we're going to do, even if you've already started, I do want to label some of the pieces in this picture. Which two sides are the legs? Darian? The two with the tick marks right here. Good. So GF right here and GH, these two sides have the tick marks. These are my legs. So I would like you to label that in the picture. Which two angles are your, or sorry, no, before we get there, what's this last side called down here at the bottom? That's called the base. Good. And it's B-A-S-E, not B-A-S-S. Right, the base, the bottom. Okay, who can raise their hand and tell me which angle is the vertex angle? The vertex, Ryan? The 40 degrees one up at the top. Good. This one right here is my vertex angle. And who can tell me which ones are my base angles? F and H. Now, I put one arc mark around the vertex angle. What should I put around the base angles? I better put two. I better show that it's different. Or you could put two on this one and then one on these both. I don't care how you do it, but you do have to show that H and F are the same, and then G is the one that's different. So F and H, these are my base angles. Okay, so now we've got everything marked up. So here's what you know so far in this picture. You know angle G is 40 degrees. You know angle H is 11x minus 18 degrees. And I want to solve for x first. Who can tell me what you think you should do for this problem? Kiki, what do you think? Oh, so close. So close. Here's what you've done. You've added up 1, 2 angles to give me 180. How many angles have to add up to be 180 in the triangle? All 3 of them. Now, this one's got nothing over there. What is angle F? Which one is it? Kiki? It's the same thing as which one? H. So what does that mean angle F has to be? It better be 11x minus 18. It's exactly the same thing, right? So I'm going to label that in my picture. Yes. Sure, set up the equation.
11x minus 18 plus 40.
Oh, you just did the same thing Kiki just did. You better add all 3 of the angles together, friend. You're only adding 2 of the angles. That means you're like, it's not closed anymore. You're only adding half of it. You got to add all 3. So you have to add together angle F, angle H, and angle G, and set it equal to 180. All 3 of them. If you only add up 2, you're not going to get the right answer. All right. 11x minus 18 plus 11x minus 18 plus 40 equals 180. Woo-hoo! It's a great, super fun algebra problem. I know you guys love algebra so much. Hooray! Okay, Who's gonna walk me through it?
Google says it's 8.
What?
Yep.
Google's right.
What is that? What?
Who was right?
Ryan, walk me through it.
So yada yada simplify. You get 22x is equal to 100.
What a yada yada. Use some math words here, friend. People are watching this video and they're gonna be like, what the heck is yada yada mean?
Yeah.
The video I'm taking right now of us. It's really just of me, don't worry.
Well.
What? Okay, what should I do?
So you add the basic like terms, so it's 40 minus 18 minus 18, so you get 4.
Okay.
And then you combine the x's and you get 22x.
Okay, so he's putting together all of the constants, all the numbers. So if you put these numbers together, you get a positive 4. And if you put the x's together, he's saying you get 22 x's. Okay, great, good. And then keep going, Ryan.
Then you bring in the 4 over the other side.
By doing what?
By subtracting it,
Good.
and you get 22x equal to 176. And then you divide 176 by 22 and divide 22x by 22. And you get x equal to 8.
X equals 8, but am I done with the problem?
It was actually.
It was actually, I thought you knew that.
I
Okay.
was actually.
Oh, okay, it really was 8. Now we're not done with the problem. Why not, Ryan? For which one? Which is which equation? Or which piece?
11x minus 8.
Good. So GFH is really just saying the one that's in the center. It's F, angle F. So angle F over here is 11x minus 18. I have to take my 8 and substitute it in for the x, right? I got to plug it in. So I have to do 11 times 8, which is 88, and subtract 18. What do you get for angle F? 70 degrees. Without doing any math, what does that mean angle H has to be? 70 degrees. And I can check my work. 70 plus 70 is 140. 140 plus 40 is 180. We're good. We did it right. Well, yeah, so there's more than one way to do a problem, right? I could have said, hey, this is 40 degrees. Out of the 180, that means I have left over 170. Or sorry, 140, my bad. 140. And then you could take that number, divide it in half. You could get what each angle is. And then you could do it that way, right? That's another choice. You don't have to do it this one way. That's the fun part about math. There's a lot of ways to do it. Yeah. You'd still have to do algebra, but it's a shorter algebra problem, right? So what you could do instead was just put 11x minus 18 equal to 70 and solve it that way. Both would get you the same answer. Good question. Okay, grand. Any more questions? We're good on that one? Ready to do a second one? Okay, number 2. Solve for x. Now, first thing we're going to do, just like in the last one, we're going to identify some pieces here. Now, which two, well, actually, why don't we do this? Because I don't have letters. Let's put A at the top on the left, B on the right, and C at the bottom, just to help us out as we talk about them. Which two sides are my legs? We don't know. Why not? Doesn't have the tick marks. Okay, there's no tick marks. Do you know which ones are your base angles? No, because you don't know all of the angles. So right now I know 2 of the angles. I know angle B and angle C. But I better figure out what angle A is first before I try to do anything. Because if I don't know which ones are my base angles and which one is my vertex angle, I can't do anything for the problem. How would I figure out what angle A is up there?
You'll have to add those 2 together.
Add what 2 together? The 64 and 52, and then what?
Subtract from 180.
Yeah, do you remember doing this?
Yeah.
Looks something like this, right? To find angle A, we're going to take 180 and we're going to subtract the 52 and 64.
106.
Does that look familiar? Is that coming back to you? Yeah. Okay, what do you get?
116.
Okay, and if you subtract that from 180, what do you get? 64. 64 degrees right there. So yeah, add these two, you get 116. Subtract that from 180, you get 64. So over here at angle A, I'm going to put 64 degrees. Now.
Which means that it goes to, you put the ticks.
Well, first I'm going to put the arc marks on my 64s to show that they're the same. Okay, which one's your vertex angle?
52.
52, angle B, this is my vertex angle. Good. Which means these two are which angles at the bottom?
A congruent.
And what are they called?
Arc marks.
What are the angles called?
Acute.
What are the two angles called that are exactly the same? What are these angles called? Thank you, base angles. Base angles. Now again, look, don't let it be fooled. They're not at the bottom, right? Base does not mean it has to be at the bottom, but you also can just turn your paper. There's my base angles, which means what about these two sides?
They're the same.
They're the same. So I'm going to put a tick mark on them to show that they're the same. Those are the, what sides are those called when the two sides that are the same? The legs. Good. Okay, so I've got my two legs, and I'm trying to solve for x. I know my legs are congruent. What should I do with my equation? Why? Because they're the same. Yeah. So congruent means they're the same. I'm just going to take the two angles and set them equal. Or two sides, excuse me, and set them equal. Ta-da! And then all I have to do is solve that like an algebra problem. Hooray! What should I do first? Sure. You can add the 8. Why not? I wouldn't do that, but sure. Live your life how you want to live it. I'm cool with that. I can change. Okay. Now what, Kiki? Since you were so adamant about the 8, what should I do now? Subtract that 6x from both sides. Good. Okay. Hey, Kobe. 4 x's, and then what? Divide by 4 on both sides. You get 3 equals x. Do I have to do anything else? Nope. This problem says solve for x. I always read the question. You could plug it in, but I don't ask you to. So like, you know, don't do more work unless you need to. Read those questions. You could, but just take longer. All right. Thumbs up, thumbs down, thumbs to the middle. How do you feel about isosceles triangles? Do you feel like you could do some problems like that? Yeah, some problems like that. Okay. Yes, you can. 52. Oh, we're fine. We're fine. We're fine. Go, go, go. We'll finish the front. Okay. First type of triangle, isosceles. Now we're going to go to our second and last type of triangle. Equilateral triangle. Equilateral. What? Why?
I don't know, I just don't like shapes.
We have the shapes to most.
I only have paper towels in my bag. You know, what did shapes ever do to you?
Actually, I had like PTSD from whenever I was little. My little sister threw a toy like cube at me.
Well, that seems like a problem with 3D shapes, not 2D shapes. So you can have that fear when we get to 3D shapes, but not for 2D shapes. Okay. All right. Equilateral triangle. What is the root word?
Equal.
Equal. Yes, equal. So an equilateral triangle is a triangle with 3 congruent sides and 3 congruent angles. So all 3 sides are exactly the same. All 3 angles are exactly the same, which you kind of see in that picture there, right? You've got 3 tick marks. Sorry, it's really blurry. You got 3 tick marks on all the sides, and you've got 3 arc marks on all of the angles. Now, let's think about this logically for a second. Inside of the triangle, your angles always add up to be what? 180 degrees. So, in an equilateral triangle, what does each angle always have to be? Good. How'd you get 60?
Because 6, 12, 18, 0, you get 60.
Yeah. Divided by 3, right? So 60 plus 60 plus 60 is always going to give me 180. So in an equilateral triangle, always the angles are 60 degrees. Always. Always. So I'm going to even write that right above it. In an equilateral triangle, each angle is always, no if, and, or but, 60 degrees. Always, always, always. And so the two theorems there just say that same thing. If I tell you all three sides are the same, automatically all three angles are the same. If I tell you all three angles are the same, automatically all three sides are the same. Okay, so we're going to use that information now to answer two questions. Okay, in the first one here, it says solve for x. Okay, now I give you that all three sides have a tick mark. That means all three sides are the same. What does that mean about all three angles? They're all 60 and they're all the same. So I would like you to mark that in your picture and get into a habit of it. Okay. So if angle N is 8x minus 4 degrees, what does angle L have to be?
8x minus 4.
What does angle M have to be?
8x minus 4.
Okay, great. So now you know all three angles. How can I write an equation to solve for x? Who can raise their hand and give me an attempt here? Maybe someone who is not the two of you, because the two of you have been answering every question. No, somebody else. I'm just gonna ignore you.
Go sit.
Yes, Sydney, go for it. What? What do you think? Give us an idea. Add them all and set them equal to 180. Good. So you can write 8x minus 4 plus 8x minus 4 plus 8x minus 4 equals 180. That is one way you can do it. What's another way you could do it? Yes, Sarah.
8x minus 4 times 8.
Okay, so you could also take the whole equation, this, multiply it times 3, and then set it equal to 180. Good, that's another way. What's another way? Yes.
180
Well, so it's a good attempt, but here's the issue. You've got a variable in there, and you have to have it set equal to something in order to solve it. So you're kind of on the right track. You've got a good idea. What does each angle have to be worth? 60.
No.
So wouldn't it be true that this equation right here should equal 60?
Yeah.
So you've got choices, and that's what I was trying to say before about the last problem. There's a lot of ways to do this problem. If you like to add everything together, this plus this plus this, set it equal to 180, that's fine. If you want to multiply this times 3 and set it equal to 180, that's fine. If you want to take it as a shortcut and say this single equation is equal to 60 because each angle is 60 degrees, that's also okay. They'll all give you the same answer. I'm going to set it equal to 60 because I'm lazy. I don't want to do that much algebra, so I'm going to do a cheat. Well, it's really just a shortcut, essentially. Oh, look how much easier that is, right? Than having to write the whole equation out. But you're still going to get the same answer. So what should I do first? Add the 4. Oh my gosh, look at that. Do I have to do anything else?
No.
Nope, I'm done. Right? That's quick. It's quick. Again, though, there's nothing wrong if you wanted to write it out and set it equal to 180. There's nothing wrong with that. It's just a little bit more algebra. That's all. Okay, last one. Hold on, I'm holding on. Okay, last one. solve for x, then find the length of BA. Now, someone raise their hand and tell me something that they notice about this problem. Kiki, what do you notice? What do you mean? Ooh, I have a question for you. Are these angles?
I mean, no.
They're not angles. They're not bases. So hold on a second. There are 3 angles inside of this triangle, right? All 3 of those angles are what? They're equal to each other and they all have to be what? 60. However, these are not angles, friends. They're on the outside. What are they? They're not the bases. They're just the what? They're not the angles. They are the
Sides.
the sides. Oh man. Okay, how about we do this? Okay. These are angles. This is a side. So if it's on the outside, oh, there we go. Outside, it's a side. If it's on the interior, it's an angle. Now, what do you know about the sides of an equilateral triangle? They're all exactly the same. So let's mark that in our picture. They're all exactly the same. So if they're the same, what should I do with these equations? Set them equal because they're the same. They're equal.
Yeah.
Don't ever, so here's the thing. Don't ever, these are on the outside. Don't ever set those equal to 180. That's only for the inside. Okay, outsides, these are the same. All I'm going to do is set them equal to each other because they are congruent. And then it's just a little bit of algebra. So what should I do first? Which one? Okay. Okay, then what? Wrote that a little too big, didn't I? 14 equals 2x. What does that mean x has to be?
7.
Okay, so x is 7, but the question asks me for the length of BA. How am I going to figure out what this length is over here?
What is triangle offside?
Because it's just a little tilted.
45.
How'd you get 45?
I plugged things right.
Which one?
Doesn't matter.
Why?
They're all equal.
Oh, they're all exactly the same. So figure out one of the sides and you figured out all of the sides. It does not matter which one you plug it into. But you have to plug it into one of them. So, I ran out of space. I'm going below. I'm going to plug it into this one right here just because that one looks easy. 6 times 7 plus 3 is 42. Plus 3 is 45. So all 3 sides are 45. 45, 45, 45. All are the same. Okay, now take 1 second. Take a moment. Here's what I want you to do for our last 3 or 4 minutes. I just want you to take a second. I want you to just digest what we just talked about. So I don't want you to talk. I just want you to look back at what we just looked at. Take 2 or 3 minutes just to reread it. And down at the bottom here, I want you to write if you have any questions. So I want you to take a sec. I want you to write if you have any questions. And I also want you to take a second and write something that you learned. If you don't have questions, that's fine. But I want you to take 2 minutes, the last 2 minutes of class here. I want you to write any questions that you still have, and I want you to write down one thing that you learned from today. Right at the bottom. You don't need to talk, just write it. Bottom of your paper.
Oh.
Bottom of your paper. Right where I did mine. I want you to take a second. If you have any questions, write them down. What you learned. And you've got 2 minutes. Just digest, and then we're done for today. But do not start talking.
Why does everyone move so slow?